Hello and greetings, everybody. This is Mark Kuhar, editor and chief content director of Rock Products Magazine, and I'm pleased to welcome you today to our seminar, our webinar, Cyclones versus Screws, the fine line between profit and loss. You know, fine material handling is one of the easiest places to lose money without realizing it. This webinar clears up confusion between cyclones and sand screws so you can protect your gradation, reduce your waste, and get more saleable ton for your operations. I'm joined today with John Bennington, Technical Sales Manager, Washing for Superior Industries, and also Lauren.debow, Applications Engineer, Washing for Superior Industries. Welcome. How are you guys doing today?
Wonderful, Mark.
Well, John, you and I go back a long way. It's probably been about 1,000 years ago that you were working for Greystone, I think, when we met, and you were very knowledgeable then, and Superior was very lucky to get you on board and take a good advantage of your expertise.
Well, I appreciate that. Yeah, no, it's been a great relationship over the years.
And Lauren, you and I haven't known each other that long. In fact, we just met at ConExpo ConAg this year, but a lot of people are saying a lot of good things about what you're doing for them in the marketplace, and it's good to hear that kind of feedback. I think when we were at ConExpo ConAg, you and I decided that the Browns and the Lions were going to be in the Super Bowl this year, didn't we?
I think so. I think that's what we boiled it down to.
I think we pretty much concluded that that's going to be the case, and just like 1954, the Browns are going to win, right?
Somebody's got to do it. Why not them, right?
Well, we're glad to welcome you both to the webinar today, and welcome to our audience out there. Our audience will be taking questions as we go. If you click on the Q&A button throughout the presentation, you'll be able to ask questions, and we'll get to those at the end. But to start us off, for someone new to washing, how would you explain cyclones versus sand screws?
Well, basically, they do a very, very similar job. I mean, the end result hopefully is very similar. It's just they get there from two different pathways. One is obviously with the sand screw, and I'll let Lauren describe the cyclone part of it. But with the sand screw, it's relatively low horsepower. It is can be a fair amount of water. It's very silt dependent. So more silt means more water. Makes sense. You got dirtier clothes, you're going to need more water to clean them. But again, low horsepower, variable amount of water, very reliable machine, does not break and crash immediately when it has a problem. It just slowly needs over the years maintenance. But that's basically the side of sand screws.
Yeah, and for cyclones, I mean, both pieces of equipment here are going to be trying to remove that bottom end of your material. So whether you're trying to get rid of your 150 mesh minus, your 200 mesh minus, maybe something a little coarser on 100 mesh minus, both pieces of equipment are going to be able to do that. It's just a matter of how and what fits better for your operation, your situation. So cyclones are a little bit more finicky than sand screws for sure. They don't have any moving parts. And I think that's something that makes people really frustrated, if not confused about them. So they're pretty dependent on how they're fed. In theory, you can feed them with gravity, right? Just no pump or anything. Please don't do that. It makes it way more difficult to control. So typically you've got a pump doing most of your mechanical work for you.
In terms of water usage, are you seeing around the country issues with water and how that applies to using this type of equipment?
Oh, extremely so. I mean, especially on the west coast of North America, the United States in particular, you're seeing and water is an extremely big concern as far as how you run the plant. Honestly, I think one of the things, and this is slightly off our topic, but one of the things that I think a lot of our producers don't really realize is it's not how much processed water goes through the system, it's how much of it you can recover. And that's really the key, because water that goes into the stockpile is water that's lost. Everything that goes back to your settling system or your settling ponds or your thickeners, that's not lost. That's just temporarily somewhere where you need it to be processed. So, but yes, water is an extremely important thing throughout the United States.
So from a technical standpoint, what's actually happening inside each of these systems when the material enters? And tell our listeners why that matters.
You want to start, Lauren?
Sure. Yeah. So within a hydrocyclone, as I mentioned, there's no moving parts. So as the feed moves in, it'll come in through what we call the feed inlet. And in that inlet is where a lot of geometry starts to take effect. So the inlet design varies from manufacturer to manufacturer on cyclones. And as the material enters that inlet, the inlet design helps guide the material around and helps control some of the turbulence and separation right there, right off the bat. So as the material comes in, it comes in kind of tangentially, so along in a curvature, and it starts to spin around. And as it does, the coarser particles are thrown to the outside. If you like the edges of the piece of equipment. So if you think of those carnival rides when you were a kid and you go and you get strapped in and it spins really fast and it pins you up against the wall, that's what's going on with those big particles. But then there's also an air core that forms in the middle of the cyclone that creates a little bit of a vacuum effect, and that helps pull out the water and the fine material. And that's how you make your separation. So all of your big coarse particles will go to the sides and drop out the bottom, and then that air core will pull in your water and your fines and pull that up and out the top of the cyclone.
So sand screws are, in a sense, a little bit simpler. The material is fed into the screw. It should be slurried already, so it should be in a semi-liquid form. If you can imagine, the back end of a sand screw is a very large vessel. We've got water being introduced into that system, plus the water that came in with the material. That creates an upward current of water, just like when you fill a glass from a faucet, the water rises inside the glass. And depending on how much water you're putting into what size vessel determines what stays in the screw and what comes out. The water and the material we want to remove comes out over the weirs. So there's a weir on three sides of the screw, and the water overflows that area, taking out the material we don't want. The heavier, bigger particles sink to the bottom of the screw tub and are captured by the auger and pulled up the incline. And as they come up out of the water line, there's an area between the water and the discharge point called the drain board. And that's where the excess water that's in the sand drains out and goes back to the settling area, and then discharges onto a conveyor belt to ultimately be on a stockpile.
Interesting. In terms of misapplications in the field, what are some of the most common misapplications of the technology in the field today?
I think there's a bit of a thought that cyclones can do things that sand screws can't, and that sand screws sometimes can do things cyclones can't. I mean, they get to the same end point when we get right down to it. It's a matter of which road do you take to get there. So probably the biggest thing I run into on misapplications are people who have a variable feed coming in, so the tonnage is going up and down, and they feed that to a cyclone system. Cyclones like steady state. They want to be turned on first thing in the morning, and they want to be turned off when you go home at night. If you're stopping and starting throughout the course of the day, that gives them fits. And whereas a sand screw, a little less concerned about that. So if you got a variable feed, you're probably better off looking at a sand screw. I have seen also situations where you've got a fairly fine feed, which would require our sand screw to run really slow. So we end up with a very, very large screw to handle a fairly fine sand. And in that case, you would probably be better off going to a cyclone, because the cyclone doesn't care about how fine or coarse the material is, generally speaking, to make its final product. So those are the kinds of things, and that's not all of them. Lauren's probably got a couple other instances, but those are the two that I see the most common.
Let me know if my mic is any better now. I would say one of the big misapplications I see, especially with sand screws, is when you have too much water. One of the common things I see is sand screws will get sized just off of the tonnage that they're looking to produce, and people don't account for the water volume that they have coming in. So, as John mentioned, there are those weirs where everything overflows that you want to get rid of. Well, if you have too much water that's going to get over those weirs, it'll take more material than you want with it. So I'd say that's probably one of the biggest things I see with sand screw applications. I also see with cyclones, you can have a siphon assist on them, which helps amplify that vacuum and pull out more water in fines. And I see a lot of people who will get the siphon assist with the cyclone, but they don't necessarily need them, and they'll end up causing more problems for themselves by sending off material they actually want to keep by utilizing them.
So then to simplify a little bit, so we can kind of keep everything straight. What are the, in simple terms, what are the pros and cons of each of these types of washing?
So for sand screws, I would say the probably the couple of 2 or 3 biggest pros are fairly low horsepower per ton. Generally speaking, about 0.2 horsepower per ton. They're fairly, I wouldn't say low maintenance. They are maintenance. When they need maintenance, it's fairly obvious. Everything's out in the open. You can see inside a sand screw. So when something's worn out, you can replace it fairly easily and know that it needs to be replaced. It's fairly continuous maintenance too. It's not something like I've got to shut the whole plant down for a week and completely change out everything inside of it. I can, replace half a dozen wear shoes or put a new bearing on. So I'm down for a few hours, but not the entire day. So those are probably the pros. And you could do, and they are very happy with inconsistent feeds. So generally speaking, like after a classifying plant, or if you're in a portable screen screw type setup where you're on the side of the road and you're just digging up material, and the loader has to load your plant and load trucks, so the feed will come up and down over the course of the day. Then a sand screw doesn't mind that. You can underfeed a sand screw and it won't care. It'll make, if you have a 200 ton an hour machine, but you only feed it 50 tons an hour, it will give you the same product as if it was being fed 200 tons an hour. Mm-hmm. The cons would be is that probably one of their biggest cons is that they're very quiet and they die in the corner with nobody paying attention. So they don't immediately, they aren't like a crusher or a screen where when it has a problem, it makes a horrendous noise and everybody in the plant knows it has a problem. A sand screw, I've seen sand screws that should have been maintained 2 or 3 years earlier and are still running okay. And that's probably the biggest ones. The other ones would be is that they are extremely dependent on silt content. So for every ton of silt in your raw feed, you need 50 gallons a minute of water. So you see in a lot of cases, especially in some of the limestone type quarry applications, where they're 15, 20, 25% minus 200 mesh in their feed. Well, that ends up with a lot of water very quickly. So that you end up with a very large screw to handle the water, but you're only feeding a fairly small amount of tonnage to it. So.
For cyclones, I think the biggest pro for cyclones is their efficiency. There's a lot you can do to fine tune them to really get them to perform the way you want them to do. So that's probably their biggest point there. The other thing is footprint, because cyclones typically tend to be functioning on more of like a vertical structure. So yes, there's a pump. You'll probably have a dewatering screen, or you might just be stacking into a pile, but you're going to be going vertically as opposed to spreading out more. So they're better for a compact footprint. Some of the cons, John kind of touched on this too. They don't like weird surges and large variables in their feed. So they are a little bit finicky in that way and a bit touchy. But if you've got a pretty consistent feed to it, pretty consistent deposit, I mean, obviously all deposits are going to have some change to them, but as long as you're not having big wild swings on a regular basis, then they'll be a workhorse for you. There's a bit more maintenance because of the pumps and then checking the liners. But they kind of give you a little bit of warning as it wears out over time, as opposed to all of a sudden just done.
let's say you're a producer and you've made your choice of which you're going to use, um, but you're concerned maybe you made the wrong choice. How does that show up in final gradation or product quality? How does the producer know?
Well, I think if you end up using a cyclone when you should have used screw, you're probably not going to see it in your finished product. You're probably going to notice it in your input costs. So your electricity costs will be a little higher than they would be with a screw. Um, Maintenance is very similar. It tends to be lumpier in the cyclone systems, like Lauren just said. You may have 2 3 years before you have to do anything, but then you have to replace a pump impeller, and that's not small. Sand screws tend to be more even. You have to replace a dozen or 2 dozen wear shoes every couple of 3 years, but that's not as big a number. However, the but they're very similar amounts of money. When you get to a 10-year average, I think you'll find that they're almost identical in price. Really, it's just the input cost more than anything else. Now, if you're pairing a cyclone along with a dewatering screen, you're going to get a fairly dry product stockpiled. In fact, we would call it mechanically dry. There's not really any water coming out of the stockpile. You don't have trucks driving out of in your pit, draining water onto the county road, which makes the county unhappy. You're not selling water to your customers. You're only selling them the sand they ask for. There are screws that run dewatering screens on them, and you will get the same results. But obviously, most cyclone systems are paired automatically with dewatering screens. That would be the big thing you would notice. If you pick a sand screw when you should have picked a cyclone, probably the thing you're going to see, maybe not see, but you will have potentially have paid more in capital costs to get to the same product. So one of them it tends to be, and Lauren, correct me if you disagree, but I think you'll see more in input costs with cyclones if it was the wrong choice, and more in capital costs if the sand screw was the wrong choice.
I think the only other thing is if you put in a sand screw where you should have put in a cyclone, it goes back to that water volume situation. You may need multiple sand screws to make up for one cyclone plant if you have a water issue, right? So if you have too much water going to your sand screw, you'll notice it because you're going to end up with a lot more material in your settling ponds that you could be selling. So then you also have the pond maintenance on top of the lost product.
Let's say you're a producer and you're considering one or the other. What's the simplest way to match up the right equipment to the right application?
Call us.
Just going to say exactly that.
Well,
Talk to your manufacturer. They're that us and most of our competitors will be very similar in this way. Is they're going to give you their thoughts. I would recommend that you talk to manufacturers that have both choices, because obviously Superior has both options. It's not really going to matter to us specifically if we recommend one or the other. Not to say that other dealers or other manufacturers wouldn't give you an honest opinion. I'm just saying their incentives are different. We would, but yeah, talk to us. I would say the big things to look at are your feed gradation. That's going to be the first and foremost important thing to know, and the second would be to know the environment that you're producing it in. Again, if you're a dredging operation, you might think one direction. If you're a quarry, you might think it's a slightly different direction. So
we're also going to take a look at like John mentioned, just the overall environment there, right? What does your footprint look like? What kind of water do you have coming in, and what's your water availability? What are the people like on site as well? We've kind of talked about some of the maintenance issues and some of the operating conditions as well. And sand screws, like John said, are very much a set it and forget it kind of a piece of equipment. You can kind of let it just chug along and do its thing, especially when there's variability. But for cyclones, you need to have somebody who's going to understand how to run them. And if things get a little wonky in the feed, how are they going to make adjustments to make it work right and get the product that you want?
I know we touched on this 2 questions ago, but just to kind of clarify it just a little bit more. When does a cyclone outperform a screw, and when does a screw outperform a cyclone?
I think the
So,
most simple application for when cyclones would outperform a screw is when you start looking at a fines recovery setup. So cyclones can be applied in a lot of different ways. If you're just making a concrete sand, again, it's going to come down to your people and the conditions of the application. But if you're trying to do a fines recovery or you want to recover more material, you'll have better control over that with a cyclone.
I'd agree, especially, I mean, if we're defining fines as anything minus, say, 100 mesh.
Right.
Um, I mean, there are cyclone systems out there that'll capture down to 400 mesh. There are industrial cyclones that'll go down to 600 mesh. Obviously, that's not in the aggregate industry. So that I 100% agree. I would say on a more typical construction material side of it, if it really is very application dependent. So please don't take this as a broad rule that applies to everyone. But the dirtier the material, you probably would lean a little bit towards a cyclone. And if it's a clean, relatively clean, and I'm not anything less than say 15% minus 200 mesh in the raw feed, then I think a concrete sand would fit very well into a sand screw. If you're trying to make a mason sand or you're trying to deal with something that's relatively dirty, I think you're going to lean towards a cyclone. And those are extremely broad strokes there.
Lauren, anything to add to that?
I think we've also found that cyclones tend to handle certain industrial sands better as well. Like frac sands tend to do a lot better with cyclones than they do with sand screws. And part of that is because of the gradations that are being targeted, the feed that's going in there. But there's also the efficiency factor in how it moves through the piece of equipment.
Gotcha. I know we've talked a lot about either or here, but when does it make sense to use them both together?
We've actually had, I think, 3 plants in the last year that we put in that had one of each.
Nice.
They tend to be classifying plants where we're coming in and feeding a classifying tank, and the concrete sand or the asphalt sand goes to a sand screw because we can run full tilt on that. And then the secondary sand or the mason sand or whatever the specialty sand is goes to a cyclone system.
We've also had cyclones piggyback on fine material washers, especially when you get like an inherited system with a fine material washer. If you start to change or have more water or something, you get additional losses of material you'd like to recapture. We're seeing more opportunities to put a cyclone in as kind of a scavenger to help recover some of that material. So it stays out of your ponds and ends up in your product pile. And then we've also seen where it turns out deposits are not actually getting better, right? You're kind of getting into crummier, dirtier material. So we've seen a lot of opportunities for cyclones to help as like a load relief to pull out some of those fines before it goes into a sand screw. There are some times where we've seen it can help reduce the overall amount of water that's required. I saw a question pop up where someone was asking the water to solids ratio where the cyclone and screws operate. And cyclones are pretty finicky in that they need no more than 30% solids in the feed. That's pretty much the target for most cyclone applications. So it can be more dilute than that. But if you've got more solids than that, they really struggle. So like feeding a cyclone direct from a classifying tank that's got 50% solids coming out, that's not going to be a great fit. But sand screws, no problem. You can put that 50% solids in there and they'll chug right along. The only catch is that if it's a drier slurry coming in and there's still a lot of fines in there, you may have to add additional water still with that fine material washer to dilute.
Yeah.
Gotcha. Let's talk for a second about cost of ownership. Where do the real dollars add up over time with each of the technologies?
Well, like we were talking earlier, I think the maintenance is relatively similar. On a sand screw, you're going to replace about a third of the wear shoes every 3 years. So after about 4 or 5 years, you're going to be replacing a third of the shoes pretty much every year. And then you're going to replace the seal and sleeve at the lower end probably once every 2 years. So, in the course of a 10-year time frame, you'll have replaced all of the wear shoes on the screw once, maybe once in 1.5 times, and the lower seal and sleeve you will have replaced 4 times, 5 times. So none of those are very expensive individually. Maybe a third of the wear shoes, depending on the size of the machine, is going to be in the $5,000-$6,000 range. With current prices, obviously things change all the time. The lower seal and sleeve together are about $300 a piece. So and then obviously you've got your labor time, but you're going to be doing work on it. Nice thing is that you can do, like I said, the nice thing about sand screws and to some extent Cyclones is they can be repaired when you choose to. If a wear shoe is worn out today, you don't have to replace it tomorrow. You can wait to your scheduled maintenance day, maybe the day you're changing out the liners on your cone crusher. You go and you fix the sand screw wear shoes as well, or the wear sleeve or something like that. So that would be the case. So you're looking at maybe, over the course of 10 years, maybe 30% of the original cost of the machine, 25% of the cost of the original machine. I think you'll get to the same place, and Lauren can correct me again, but I think a cyclone system, including dewatering screen, a pump and sump, all the external pieces, you're probably going to go through at least one apex a year. Would you say, Lauren? Maybe I should just let you say it.
Yeah, so the cyclone itself is not particularly maintenance heavy or expensive. Like John mentioned, you'll probably replace the apex sometimes twice a year, maybe once a year, maybe once every other year. It just depends on the material that you're producing. But you do have the added maintenance costs and even capital costs of the pump and other accessory pieces of equipment that you'll have to maintain. And then, as has been brought up before, the operating costs of a cyclone plant tend to be higher than a fine material washer as well. There's more power required for the horsepower on the pump and the dewatering screen motors. So that's really where it kind of sinks in.
We got some questions in the queue here. We'll get to those in a second. I did want to ask one additional question. In terms of parts and service, how are the parts and service dynamic working these days? I know we have a lot of weird international conditions and different things happening in our own country, but parts and service readily available, working okay right now?
Yeah, haven't really seen too many issues. New machines are a little bit of a challenge nowadays. I think all the manufacturers would agree to that. Steel is not something that everybody has in their back pocket, but we have not had anybody have to wait 6 months for a wear part or something like that. No, generally speaking, I think we're looking at on long lead time things are like a couple of weeks, and most things are in stock.
There's some variation there. There's certain materials that are used for the shoes on the fine material washers. You've got rubber, urethane, maybe some metal options, right? And then for cyclones, you're looking at rubber, urethane, maybe ceramic. So a lot of the rubber urethane components we can get relatively quickly, especially domestically. There's a lot more options to have those here. Some of the casted parts, they can be a little more hit and miss, right? So it just depends on who your supplier is and where the manufacturer, your dealer is getting them from.
Excellent. Let's get to some questions here. We've got a few really interesting things coming in from our audience today. Are cyclones better compared to sand screws for overall sludge and water recycling in a fully closed system with a thickener and filter press?
I would say so. You've got a lot better ability with cyclones to capture, like we talked about, those fines and super fines, so your minus 100, minus 200 mesh material. We can also put in like fines recovery systems that are cyclones specifically for capturing stuff that might bypass the sand screw to help with your water recovery and solids recovery, keep stuff out of your pond.
Yeah, if we're talking about fines recovery, then cyclones are the answer. And I do highly recommend, actually, that if you are doing a thickener system or a filter press system, that you really seriously consider cyclones. It'll reduce your day-to-day expenditure on your recycling system by a decent amount. Generally speaking, the chemical costs required for thickeners is tonnage related, and a good fines recovery cyclone will capture about half of the solids. So that immediately reduces your chemical cost by half. So, and it's not uncommon for some of these bigger plants to be paying tens of thousands of dollars a year in chemical costs. So you can imagine the savings adds up pretty quickly.
Interesting. One of our listeners is wondering out loud, cyclones are more complex to operate and maintain. Would that be accurate, or is that wrong?
I don't know that the cyclone itself would necessarily be more complex to maintain. They're pretty simple, pretty straightforward. There's really two parts that would get changed out regularly on a cyclone, being the apex at the bottom and the vortex finder in the top of it. The liners themselves, that varies from manufacturer to manufacturer. Some have drop-in replaceable liners, some don't. So you might just swap out full cone sections if you have to. So on the maintenance side, the cyclone alone is not that bad in terms of maintenance. You start adding in the pump and things, then obviously there's more to consider. And in terms of operation, I would agree that they're more complex because there's more that you can do to adjust them and fine tune them. So there's a lot more you can adjust, like your water rate, your feed pressure, things like that, where on a fine material washer, you can adjust speed and silt dilution, really. And that's probably the bulk of what you would be looking to change. So I could see where you would consider cyclones more complex.
I think we come back to the cyclone question about being complex. They are, like Lauren said earlier, again, talking about the environment. Is your feed going up and down? Do you have maintenance crews and operating crews who understand the machine? If they don't, then they can't understand it. I would say that cyclones need a lot of data for the customer, for the customer to understand. And when I say data, I mean pressure gauges. If you've got a flow meter, that's not a terrible thing to have. But I've seen a lot of cyclone systems over the years, and this, talking about misapplications from earlier before, that's probably the biggest problem with cyclones is people don't put gauges on them, or don't buy that as an option when they buy the system. And if you don't know what the pressure is in a cyclone, there's no way for you to really understand if it's doing its job or not.
Or at least where to start troubleshooting them. That pressure will tell you a lot about it. I mean, if you can tell me what your flow rate is and you know how much solid you're feeding into it, great, we can back into that. But if you have a pressure gauge on there, that'll tell us a whole lot more with a whole lot less data collection.
Yeah.
Okay, we have another question here. What is the optimum water to solids ratio at which a cyclone and screw operate?
Well, Lauren said earlier the max of 30% solids for cyclones. Sand screws are a lot more forgiving about that. I've run a sand screw that was being fed, basically 1 or 2% solids, all the way up to screws underneath classifying tanks, which are getting fed like 60% solids. I've had some customers try to feed them even drier material. The problem gets to be is when you dry feed a sand screw, even if you try and slurry it as it comes into the screw, the problem is that the fines aren't getting liberated. They're not being available to flow out over the weirs until they're halfway up the auger, in which case they don't actually get washed out. So that's kind of the limiting factor. if the material coming into the screw is thoroughly slurried, in fact, every surface area of the individual sand particles has been completely surrounded with water at some point, then you're fine. And that could be anywhere in that. The high end would be 65% solids. And again, there is no bottom end.
Okay, we have a hypothetical situation here for you to address. So one of our attendees notes, we have a twin 54 sand screw paired to an 8x20 triple deck horizontal screen. 1,300 gallons per minute going to the screen. All water going to the screw is off. The problem we have is our SC is too high, mid-90s. We're considering Cyclones, but don't know if we need the screw as well or switch to a Cyclone plant without the screw.
It's a very interesting question. That's not normally the problem people have with SE. Normally their problem is it's too low. So I'm not 100% sure that I completely understand the question. So whoever asked that question, if I don't answer it the way you meant it to be asked, please ask it again, slightly differently. I will tell you this: 1,300 gallons a minute, if that's all the water that's going to that screw, is not enough for it to make a 150 mesh cut. If you're losing material over the weirs, I would assume if your SE is high, it means that you have gotten rid of all of the silt and are even losing some of the -100 mesh. I'm not sure how that would happen with only 1,300 gallons unless there's something not working correctly on the screw. If the feed is relatively fine and the sand screw is running too fast, then it will keep everything sort of fluffed up in the back end and you'll lose material over the weirs. Also, if you don't, at 1,300 gallons, you have to have at least, you can't have more than, what is that off the top of my head? 60 tons of silt is the most you can handle. 65 tons of silt at 1,300 gallons. So if you have more than 65 tons of silt, you can have silt dilution problems, which means the back end gets really thick, full of mud, and you end up losing material over the weirs again. So I guess the first step I would take is, before I put a Cyclone in, and that's not necessarily the wrong answer, but the first thing I would tell them to do is take samples of what's going over the weirs to see if there's even anything there to capture. Because if everything going over the weir is -200 mesh, you probably don't want that in your finished product anyway. It'll throw you out of spec. So capturing that with a Cyclone doesn't get you ahead of the problem. It just creates another problem. So that would be the first thing I would say. If the screw is running too fast, then we need to look at slowing the screw down. And the way you do that, way you know what that number is you look at your finished stockpile product and the gradation of it, and you take the percent passing 50 mesh. If you're 15% passing the 50 mesh, you can run at full speed. 20% you run at 75% speed, and 30% you run at 50% speed. And there's obviously gradations in between those three numbers, but that's what you need to speed up. You need to slow down to those numbers depending on what you're producing. I hope that answered the question.
And anything else to add to that, Lauren? Does that pretty much cover it?
No, baby's got this.
That was a great problem-solving analysis, John, with little information. So a couple more questions here. How do you size a Cyclone versus a screw washer based on the required capacity?
Yeah, so Cyclones are really based on a lot to do with volume. So we're going to look at the overall slurry rate coming in. But we also have to consider things like what cut are you actually trying to make, and that'll help determine a target pressure. So there's a number of factors. Every Cyclone manufacturer has their own proprietary formula and sizing for Cyclone specifically. So they're most likely going to ask you for a gradation, what you're trying to do, and your feed rates into it. And that should get them a starting point to actually size a Cyclone. Screw washers are a lot simpler. Yeah.
I was going to actually say that it was the opposite. The application side of sand screws is a little bit more complicated. Like you just said, Cyclones are volumetric. You got X amount to push through there. That'll tell you what you're going to have to some extent. And I know I'm vastly oversimplifying. Sand screws, it's going to depend on how much silt is in the feed and how many tons you want to feed it and how fine fine or coarse the sand is. Those 3 data points tell us what we need to know. So dirt, how fine or coarse, and how many tons you want to produce.
I would add one more factor to that is water volume.
Yeah. If I've already got, you're 100% correct. If I'm taking water from a dredge system or a screening system that you already know is going to be, then yeah, we're going to want to know that too. 100%.
So we have someone who says that they're getting too many fines back with the cyclone. What is the best way to resolve this issue, Lauren?
Well, first off, do you have a pressure gauge? But that'll just help us kind of figure out if you're running at too high of a pressure. So if you've made any significant changes, like added more tonnage recently or decreased the amount of water, that can contribute to getting more fines into your underflow or your product from the cyclone. But there's a number of things that you can look at depending on what is actually causing those fines to end up in your product pile. Again, starting with the pressure and seeing where that's running would be the first thing we'd look at. So I would suggest reaching out to whoever the manufacturer of the cyclone is, and getting their operating pressure and what their sizing parameters were to understand where you fall if you're operating similarly to what was expected.
I would also say this, Lauren, I can see a slightly different version of reading that question is that they had a machine that they were losing some fines with. They tried to capture some of them, and now they're capturing too many. Wouldn't that be a situation where you might want to look at a siphon assist to pull some of those fines out of the cyclone's doing its job? It's just doing more than you wanted it to. Is that a reasonable point?
Possibly, yeah. Again, it would. There's more questions than answer to this one, unfortunately.
More information needed.
Yeah.
Mark, give us a call. We'll help you out.
Absolutely.
Looks like we have one additional question here, and I'm going to read it verbatim. And it's more of a big picture question than it is a specific application question. Why don't we see new FMW manufacturers in the U.S., but more and more investing in cyclone systems for the market? Also, why aren't FMWS and classifying tanks used globally, only really having a presence in North and South America?
Question.
Yeah, I'm going to disagree with the last one a little bit. There are classifying tanks in other parts of the world. There are some in Australia. I've sold at least a couple into Europe. And there are other manufacturers that have stuff in Europe. I will grant you they are not as prevalent as they are. To a large extent, it's spec driven. So if you don't have a relatively tight spec or a spec at all, you don't really need a classifying tank. So if you are in some countries that either the sand, is an example, some smaller countries, all their geology is almost all the same. So if you get sand out of one pit or another pit, it's not radically different. Whereas in the United States and North America, really the whole of the Americas, we have such a varied geology, and we're a fairly large country. So, you want the interstate that starts in Philadelphia to function the same when it gets to San Francisco. So you have to hold the producers to a specification. So that's why the federal government, not that the government did it, but the ASTM, which is a national organization, created this set of specs that everybody across the country has to meet. So the other thing is, I think there's a lot of dredging in North and South America, and dredges lend themselves naturally to classifying tanks because the other name for a classifying tank is water scalping tank. So that's the big thing. So specifications, some of it's the feed, and I've forgotten the other part of the question. The reason I don't think you see new manufacturers of screws, I don't think you're necessarily seeing new manufacturers of cyclones either. I mean, Superior got into cyclones, which hadn't been before. but that's the only new manufacturer of cyclones. There are a lot of companies out there that are systems companies. They're buying parts of machines from all kinds of people and marrying them together into systems. They aren't necessarily manufacturing. The manufacturer of the Cyclone is the same for two or three of those um, consolidators, I guess, is for lack of a better word. And they're coming up with a system that works that way. So I don't think you're seeing a lot of new Cyclone do it. I think, at least in North America, cyclones are the new cool thing. They weren't necessarily the cultural thing that was done here for the longest time. I think again, they were invented at roughly the same time. So they're both of them are 120, 130-year-old technology. It's just a matter of what wasn't being done here versus there.
I would add, I think we're seeing a lot more cyclone systems coming to the market, partly because there's an international influence on a lot of those. So a lot of those systems are being manufactured in Europe, right? And it's very European to have those cyclone systems, partly because of the smaller footprint. They don't have near the same area for their sand processing that we have here. So those compact systems are kind of the vibe over there more than they are here. But you'll notice they're definitely making their way over.
Well, we are right up on our 45-minute target here. John and Lauren, any final thoughts before we close out?
I think, again, we started the whole conversation. There are lots of tools in the toolkit. Make sure you're using the right one. There's not one universally better system out there. It's just a matter of what you're trying to accomplish and what you're starting with.
Yeah, I think the only thing I'd say is, as with most things in washing, it depends. So don't be afraid of options.
Excellent. Well, with that, it's a wrap. I'd like to thank John Bennington, Lauren DeBow for your expertise today, Superior Industries for offering up your expertise to benefit our readers and listeners. And we really appreciate having you today. We really appreciate everyone in the audience took the time to tune in and also to ask questions. So with that, it's a wrap. Thank you very much and have a great rest of your day.
Thank you.
Thank you.